Question 6, first three terms of an arithmetic progression are these. Given that the common difference of the progression is not 0, find the value of p. Arithmetic progression, very easy. We are given the equation of what to use for arithmetic progressions and geometric progressions in MF19, and I wrote it down there for you to see. So we know first term is p squared over 6, and that's what A stands for. Your second term is that, third term is that. So for D, we're trying to find the common difference, right? We're trying to find value of p, but we know it has to be related to common difference. So D difference is obviously between the third term and second term, and between the second term and the first term. It's always going to be constant because that's an arithmetic progression, and that's what I did. I did my third term minus my second term, and then I calculated the second term minus the first term, and the answers should equal each other because the differences are constant. Okay, and then you just solve the quadratic equation. P equals to 6, p equals to 12. Once we get p equals to 6 and p equals to 12, we have to sub it in to the first we have to sub it into one of the difference formulas because we have to make sure that the common difference is not 0. So right off the bat, we can already see that your D over here, it's equals to 0. But then we know that if you sub in 12, you're gonna get -6. That's not 0. So we only accept p equals to 12 and not p equals to 6. So again, remember to check reject and write reject. So using this value, find the sum of affinity of the geometric progression with the first two terms being those two. So for this, you can find this formula in the MF19. I wrote it down here so it's easy for us to see. A is your p squared over 6, and that's what I did. I simplified it into this equation. But then now that we know p equals to 12, we need to find r, because those are the two terms that you need in the sum of affinity equation. So what I did was I subbed p equals to 12, and then I found my r, and then I just calculated my sum to infinity from there. So in question 7, we are asked to find the greatest and least values of y. What I find really helpful is to draw it out. So we know sine x is in this graph. It's the shape of this graph. So we know over here is pi, and the greatest and least values would be 1 and -1. So once you have sine half x, right? I've drawn it out here. So what they did is basically they stretched your x-axis they stretched your graph in the x direction. So now it's twice as long, right? So you can see it ends over here for 1 full cycle at 2 pi. However, when it comes to sine half x, it stretches on to 4 pi. That's 1 full cycle. Okay? So now, what I did was I slowly added the transformations in. So my blue graph is 3 sine half x, and you can see in the y, basically it only changes in the y direction, so it just times 3. So 1 times 3 is 3, -1 times 3 is -3. So that's your greatest and least values. However, once you add the +2, which is the final transformation and is what we want, so then you can, +2 means you have shifted the graph to move up twice. So 3 plus 2 is 5, 3 plus 2 is -1. So you can see least value is the same as before. Greatest value has gone up by 4. So the greatest value is 5 and the least value is -1. So now we're asked to sketch the curve. Once again, I've already drawn it up here, but I drew it down here again. Remember to put in your maximum points and your minimum points, and put the point of intersection as well. So state the number of solutions of the equation 2 plus 3 sine half x equals to 5 minus 2x. And for this, I usually just find the coordinates of two coordinates of 5 minus 2x and just imagine them plotted on the graph. So imagine x equals to 0, y equals to 5, it will be here, 2 pi and negative 7.6 will be over here. So you can see it only passes through this graph once. The functions f and g are defined as follows, where a and b are constants. Given that f7 is equal to 5 over 2 and g f5 is equal to 4, find the values of a and b. So what we want to do is you substitute 7 as x, and that's what I did over here, and then you can just follow through and get your a equals to 3 value, and then I subbed in 5 equals to x for your f5, and then since we already have our a value, just make life easier and sub it in, and you get 4. So then you sub g4, you sub 4 into your g equation, you get a value for b in the end. That's it. So for the rest of the equation, you should use the value of a, which is found in a. So find the domain of f inverse. So right away, we already know that your domain of f inverse of x is equals to range of fx. That's just a rule that you should know, and vice versa, the range of f inverse of x is the domain of fx. So I found the equation of fx without the a variable. I just subbed in a equals to 3 to make life easier for me, and I get 1 plus 6 over x minus 3. So the 1 over x equation looks like this. This is the graph, okay? So it never touches 0, okay? And you know that, your x can go all the way positive and your x can go all the way negative. So since we know that the domain of f of x is larger than 3, we know that we're looking at this side. So my x value will always be greater than a certain positive value. It will always be greater than like the asymptote. And since we know that, the denominator can never be 0, what I'm going to do is I'm going to imagine the whole value 6 over x minus 3 as 0. And so f of x equals to 1 plus 0, you get 1. And it's always going to be larger than 1 because this being 0 is not possible. So you're going to get f of x larger than 1 as the range. And we're not looking at anything on the negative side, so it's going to be larger than positive 1 because of the domain of f of x, which is larger than 3. And then since your range of f of x is larger than 1, your domain of f inverse is x larger than 1. That's the answer. So finding an expression for f inverse of x, this is just my way. What I do is I substitute y as x and x as y. What I mean is f of x is y, and then my x is x, right? So if you look here, I just did the normal equation would be y equals 1 plus 6 over x minus 3. However, I changed my y into x and x into y, and you just solve from there, and you solve from there and you try to make y your subject, and that's what you get. In question 9, we're asked to find the rate at which h is increasing at the instant when h is equals to 10 cm. So a water is poured into a tank at the constant rate of 500 cm³ per second. Already, we know dv over dt equals to 500 from this. And we know it's v because it's 500 cm³, and we know that's a t because it's per second. Okay, so the depth of water in the tank t seconds after filling starts is hcm. When the depth of water in the tank is hcm, the volume is given by this formula. So we want to find the rate at which h is increasing when h is equals to 10. So we need to be aware of this formula. So we want to find dh over dt because that is what they're asking. H is increasing. Find the rate at which h is increasing. So to get that, we need dh over dv, and we need dv over dt. So we know dv over dt over here, and we're trying to find dv over dh by the differentiation of this formula. It gives you dv over dh, which is the inverse of dh over dv. So that's what I did. I found you differentiate v. But how you do this is you bring down your 3, and then you minus 1 over here, and then you differentiate your constant. So that is obviously 1, that's why I didn't include it here, but you can if you want. So I brought down my 3, got my 2 and 1 over here. Simplify it, you get this. And we're given when h equals to 10, so I substituted h equals to 10, and you get 4900. That is for dv over dh. However, over here is the inverse, so that's what I did. I inverse 1 over, I inverse 4900 and I times it by 500, and this is your answer. You can, it's optional to include the units, but I like to include the units. So for question B, we also have to find v, but this is another instant at which the rate of at which h is increasing is 0.075. So then we know dh over dt is 0.075, and we know from the initial question it's always going to pour at a constant rate of 500 cm3 per second. So that's what I got. So now we want to find the rate, we want to find v, right? We already know dv over dh from here. This is the formula. Okay, so if we have found dv over dh and we equate it to the formula of dv over dh, we can find h. And then when we find h, we can just substitute it into the v formula that we've been given in the question, and you can find v. This is the final answer.